figure above, find the angle of the dot. So here we can see a shape, and this shape, it includes a lot of other shapes. So the shapes are overlapping each other. So let's find some different polygons here. So if we join the lines up, we can see that the lines do not join each other in the end because it's like this is a shape, but it combines other polygons, so it's overlapping each other. So it's very hard to know the shape that includes this angle here. We want to calculate the angle over here. It says we want to calculate the angle of the dot. So here, let's try to look at a different angle. So here I'm going to draw in the middle. You can see if we join the lines up, it's a regular polygon. So that means I assume that all of the sides are the same. So it's a regular polygon. And if we count the sides, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 9-sided polygon. So this is called nonagon. Nonagon. So how do we know the angle? How does this shape relate to this angle over here? So first of all, we want to calculate the angles inside the shape. And we know that we're assuming that this nonagon is a regular nonagon. So that means all the sides are the same and all the angles are equal. So if we assume like that, then we know that there are 9 angles. So 9, there is a special formula. So first of all, if you want to make it easier, let's count how many triangles are in this nonagon. So I'm gonna use another color. So you can see this is a triangle, this is a triangle, this is a triangle, and if we continue to add them up, we have to count how many triangles there are. Remember, we cannot overlap the triangles. So let's count them. So there's 1 triangle, 2, 3, 4, 5, 6, 7. So in a test, if you want to do it faster, there is a faster way. So the formula to calculate one angle of a regular polygon, first of all, we know that there are 9 sides. So 9 minus 2, we always have to do the number. So let me just write the formula first. So number of sides minus 2 times 180 divided by number of sides. Now this is the formula. We want to know nonagon. So we know that nonagon has 9 sides. So we put 9 here. So that means 9 minus 2 times 180 divided by 9. So we will know one angle of this polygon. So because here we counted that there are seven triangles, right? Now it's the same in this formula. 9 minus 2 is equal to 7, right? So we know that 7. Now we know that 7 times 180 divided by 9. Now 7 times 180 will give us a really big number, which is 1260 divided by 9. Now that divided by 9 will give us 140. So that's one angle of this polygon. So I'm going to erase this. Okay. So you know that one angle here is 140. So all of those angles are 140. And if you add them all up, it's going to be 1260. Now if you don't believe me, you just try it by yourself. So here we know that this angle is 140. This angle is also 140 degrees. Now, if you see clearly, we can see that this is a straight line. So I'm gonna highlight. So you know that this is a straight line. This is also a straight line. Now how does this relate to calculating this angle over here? So first of all, know that a straight line always adds up to 180. And we're given that the angle over here, we know that is 140. So 140, we want to calculate the small angle here. So 180 minus 140, which gives us 40. So you know that this angle here is 40, and also the angle over here is also 40 because both of them are the same. And now we want to calculate this angle over here. So we know that triangle, the angles add up to 180 again. Now we want to know only one angle, which is this angle. And we're given that there are two angles, so which is 40, so minus 40, minus again 40. And that will give us 100 degrees. So the dot is 100 degrees.